All right, so analyzing graphs and functions of functions and relations. Okay, so for today, we're going to go ahead and start with finding y-intercepts and x-intercepts. So as a quick reminder, okay, you should know what this is, all right, with x-intercepts and y-intercepts. But essentially, right, if you have a y-axis, okay, and then an x-axis, all right, let's say you've got, let's keep it simple, a nice linear graph, okay? And let's say that, this is the point where this line, this function, intersects the y-axis, and this is the spot where the function intersects the x-axis. Okay, so let's just talk about what these coordinates are. All right, so this coordinate is 2, 0, okay, and it is the x-intercept. All right, and this one is the y-intercept, and its coordinates are 0, 3, and it's the y-intercept. Okay, so if you think about it, if you're talking about the x-intercept, okay, you'll notice your y is always going to be 0. Okay, your y is always going to be 0 for your x-intercept. Okay, and then it's kind of reverse, right? We're talking about the x-intercept, but the y is 0. The y coordinate is 0. And then reverse, right? If we're talking about the y-intercept, the x value, the x coordinate, is 0. Okay, so that's going to be important moving forward, and I will also kind of write that in here, just so we're clear. But just to get a quick visual and a quick reminder of what those actually are, that's kind of the graph for that, okay, or one example of that. All right, so y-intercept. All right, so this is where the graph intersects the y-axis. Sorry. Okay, where the graph intersects the y-axis. Okay, and the point is always going to look. You're always going to look for 0, right? That coordinate for the y-intercept is always going to be 0, comma something. Okay, so 0, comma a number. Okay, so again, it's going to be 0, comma a number. All right, so I'm going to go ahead and write the algebraic steps. Okay, so just a quick step. Okay, you're going to find f of 0. Okay, that's going to be your instructions. You literally plug in 0, okay, for x. All right, so we're evaluating the function where its x value is 0, and then whatever the outcome, that's your y-intercept. Okay, and we'll look at examples in a second. Okay, but the x-intercept, all right, similar, right, where the graph intersects the x-axis, okay, as kind of what we did over here. This time you're going to have a number first, right, and then 0. Okay, so just don't get too confused. If you ever need help, right, just draw like a quick picture like I did, right? Think about the coordinates, draw a line, intersect it at that x-intercept, or on that x-axis, okay, and think about what those coordinates are. Well, those coordinates are going to be 2, 0, so your y is going to be 0 for your x-intercept. Okay, there's nothing wrong with kind of going back and having to think about what is actually happening when you talk about that word. Okay, so for the algebra, okay, you're going to actually set f of x to 0 and then solve. So this is kind of a two-step solve for x. Okay, now just as a reminder, right, you're going to set your y equals 0. That's another way to think about it. Okay, all right, and then hopefully these steps will make sense once we actually do an example. Okay, so here we go. We're going to go ahead and jump in. All right. So f of x is equal to the absolute value of x plus 2, close the absolute value, and then minus 3. So that is the graph right here. Now, theoretically, you could absolutely use the graph to find your y-intercept. Okay, let's just go ahead and write it. Okay, it's this point right here. All right, but let's talk about how we can do it algebraically as well. Okay, so regardless, our answer should be -1, 0. Okay, sorry, flipped. 0, negative 1. Okay, so using the algebra, again, here's the steps, but we can also think about why this is the case. We know my x is 0 for that point. Okay, so instead of x here and here, right, we're going to write f of 0. So we are finding f of 0, okay, absolute value of 0, okay, plus 2, close the absolute value, and then minus 3. Okay, so again, f of 0 equals, well, we got to do inside first, so let's do 0 plus 2, that's 2, okay, and then the absolute value of 2, and then minus 3. All right, so the absolute value of 2, well, again, that's a distance from 0, okay? If this was negative, it would not be positive. All right, but for now, since it's already positive, it remains positive. Okay, so we've got 2 minus 3, and then we do get out negative 1. Okay, and then we're going to plug it back into here. So that does check with what we found in the graph. Okay, so, and again, you're going to have to get coordinates, right? So you plugged in x for 0, right? So that's why we have this 0 here, and then we got out the y value, okay, of negative 1. All right? So that's my y-intercept. Let's talk x-intercept. All right? Same thing, all right? We can look at the graph, okay? Notice that there's going to be 2 different intersections. We've got one here, and we've got one here. Okay, so we should expect 2 different answers from our work. Okay, but according to the graph, we've got a negative 5, comma 0, and a 1, comma 0. All right, those 2. So algebraically, here we go. All right, so instead of f of x, right, instead of f of x, okay, we are going to replace it with 0. So instead of all of this, okay, instead of all this, I'm just going to write 0 equals the absolute value of x plus 2, and then minus 3. Okay, so if you don't remember how to solve absolute value, what you essentially got to do is you've got to isolate it. Okay, we want the absolute value of x plus 2 by itself. So we've got to get rid of everything on that side that is not just x plus 2. Okay, so let's get rid of the 3. We're going to add 3, add 3. Okay, I've got 3 equals the absolute value of x plus 2. Okay, and if you remember what to do at this step, you're actually going to split the equation into 2 different ones. Okay, so one of them is just, let's go ahead and kind of do this. Okay, one is just going to be 3 equals x plus 2. Okay, you keep it exactly the same. All right, the other is going to be negative 3 equals x plus 2. Okay, and the reason is because of that absolute value, right? If like the output of that, right, the absolute value of 3, well, we'll get into that later. Okay, so, or you can go back and just talk about absolute value another time. All right, anyways, 3 minus 2, we get 1. 1 equals x, that's one of my answers. Boom, right there. Okay, and then the other one, we've got minus 2, minus 2. Okay, this time we do get that negative 5 equals x. Okay, and that's exactly what we have over here. All right, so that's how the absolute value works with solving that. Again, we can kind of think about why that's the case with splitting it another time. But for now, okay, when you see absolute value, you do the positive, and you just keep it the exact same, and then you got to flip it on that other side, okay, to keep it negative here, and then you just solve like normal. Okay, so that's why we have 2 different answers here. All right, let's go ahead and do, let's go ahead and do one more on this page, okay? Let's go ahead and take a look at g of x. Okay, so according to the graph, all right, so we got the y, and this is kind of a weird little function here. I'll just go ahead and say that. Kind of uncommon to see the x squared under the square root, but it is what it is. Okay, but with the y-intercept, okay, it looks like it's somewhere in here. I'm not even going to estimate it just because it looks like it's some sort of decimal or something like that. So let's just, we'll keep an eyeball, right? It's somewhere between 2 and 3. It's somewhere in there, okay? All right, but algebraically, okay, so same steps, we find f of 0. So this time it's g of 0, right? Okay, and then we just plug it in, okay? 0 squared plus 6, okay? And from here, All right, we've got g of 0 equals, well, 0 squared is just 0, so 0 plus 6, this is the square root of 6. Okay, and there it is. That's it. It's about 2.45. Okay, so you can just put 0, comma, square root of 6, and that is your value. Okay, and that is it on that one. All right. Let's go ahead and do the other one. All right, so notice with the x-intercepts, there's actually no x-intercept. Like, it is not intersecting the x-axis, right? So we should expect to get something that doesn't work algebraically, okay? So let's go ahead and look at it. We're going to go ahead and set 0, right? So 0, okay, equals the square root of x squared plus 6. Okay, now in order to solve, we've got to get rid of this square root first. Okay, you always want to get rid of that, big operation, the one that's on the outside first. Okay, so in order to do that, we're actually going to square both sides, which does get rid of that square root. Okay, so we'll go ahead and have 0, right? 0 squared is 0, and we've got x squared plus 6. All right, now we want to get rid of the 6, so we're minus 6, and we've got negative 6 is equal to x squared. Okay, so we're looking at this point here, and we should see, right, that this is actually not possible, right? You can't multiply two numbers, right? If we're just thinking about what x is, okay, x is 2, okay? 2 times 2 could not give me a negative, okay? Even if it was negative, right? Negative 2 times negative 2, still going to give me a positive, okay? So you cannot multiply two different numbers by themselves and get out a negative number. So this is not possible, okay? So there is no value. So undefined, okay, really, or like no solution is probably the best way to say this. Okay, and that's why we don't have any x-intercepts. All right. Okay, let's go ahead and go to the back here. All right, so domain and range from the graph. Okay, so we've gone over domain and range, and there's a couple different ways to do it. You've got set builder and you've got interval notation. All right, but this is just from random graphs. Okay, this is just kind of a practice in looking at a graph and then writing what the domain would be. Okay, so let's go ahead and start with something relatively simple. Let's go ahead and do this first one. Okay, so finding the domain. All right, so I'm gonna look at my domain, right, and I'm looking at my arrows specifically. Okay, so this is going down, and if it were to continue, it's going to continue. It's slightly going to the left, right? So it's actually going to continue all the way out to negative infinity. Okay, so that one go ahead. Let's just think about the other side too. So negative infinity all the way to the left, and then it continues, and then it is also going all the way to the right. Okay, so if we're going to talk about set builder, I'm just going to leave out all the squigglies and whatnot, but this is every real number. Okay, so it can be anything. There's no restrictions on my x value. Okay, and then if we were to talk about interval notation, okay, that's going to be negative infinity to positive infinity. Okay, so there's that one. Again, the arrows, right? The arrows are kind of what gives that away. So yeah, range. Okay, let's talk about the range. So what we can do with the range, right, is we can look at where it touches my pencil, sort of, right? So it's going down, right? It's going down forever. So there's no like start point for the minimum value. All right, so we'll think of that. Okay, so there's no start value, and then I'm going up on the graph, and then we see that there is a ceiling, right? So this is like the max value for my y, right? That is my max peak for the y value. Okay, so it's starting very low, and it hits that kind of wall at the top, and my y value could be equal to that, right? I could have a point there. So I'm going y is less than or equal to 4 because it's that ceiling right there. Okay. Similarly, right? Minimum value. Well, there is no minimum because I'm starting at infinity. I'm going all the way up to 4. Question is now parentheses or bracket. This one's going to be a bracket because it does touch that peak. Okay, so there's that one. All right, so let's do some of the more difficult ones here. Let's go ahead and do, let's do this one. Okay, let's do this one right here. This one's a little funky. Okay, and we'll do one more. We'll do this one after that. All right, so domain here. Okay, so this is a closed hole. Okay, if it was an arrow, it would change what's happening here. All right, but with the domain, right, I'm starting at my minimum. Okay, and we got to think about what's happening as I go across the graph. Okay, thinking about what's happening as I go across the graph. So over here, I start at that value of -6. Okay, so that's my minimum, right? Left to right, left is the minimum, right, and then the right is the maximum. Okay, so I'm starting at that -6. Is it greater than, or sorry, less than or equal to? Well, it's going to be less than or equal to, okay, because it does touch that point. Okay, and then I'm continuing along, right? I'm continuing along, and I've got a point. You know, it's all on the function. I've got a point here. I've got a point here. I'm continuing. Got points along here, and then I get to this, right? And I've got an open hole. So what you can do is maybe it helps is to kind of shade out everything that's not part of the function. Okay, in these kinds of questions, maybe it's helpful to do that. Okay, so your x value continues, but then at 4 something weird happens, right? It's an open hole. I'm actually not touching this exact spot. Okay, so I'm continuing. I've got -6, continue along, and then I hit that 4, and then we are not evaluated at that spot. So what we're going to do is we're going to leave it open. That's why we do not have the equals sign here under. Okay, that's the domain and set builder, all right, or inequality. And then with the domain for the interval, right, you just got to do the brackets and all that. So bracket here because I'm less than or equal to, so -6, comma, and then I reach that 4, and then because this is just less than, I'm going to put parentheses. Okay, so there it is on that one. All right, with the range. Okay, so same kind of thing. Let's go ahead and do what we did before. Take our pencil. We're starting low for the range, right? It's low to high, right? Low to high because of the because it's my y value. Okay, so I'm starting low, and boom, that's where I start, right there, right above my pencil, right here. Okay, and it's the lowest point, right? We don't go past it, okay, and go to that, right? Like that's above this. Okay, so I'm starting. I'm gonna do my shading, kind of like I did before. Okay, and my minimum value, okay, is that -5. Okay, so -5, and we've got to think about, is it evaluated at that value? Well, yes, it is, right? I've got a point. There's no hole or anything like that. Okay, so -5, less than or equal to y, and then I'm going up. Okay, and something that might trip you up a little bit is when you get to this, you're like, am I evaluated at this y value? Okay, well, no, it's not evaluated over here, but it is evaluated over here. Okay, so this is still included in my range. Okay, so don't be tempted to take that out. Yes, it's not evaluated at this particular spot, at that particular x coordinate. There is no y value. But over here at this x coordinate, there is a y value, and that's what we're focused on. Okay, so you're continuing up, and then you reach another peak, and then you can shade that part off if you like the shading. Okay, and we are evaluated at that closed holes, everything like that. So we have less than or equal to 3. All right, and that's what we're going to have for the interval. Okay, so -5 all the way up to 3. All right, cool. Okay, so we'll do this last one right here. Same sort of situation. If you like the shading, let's do the shading. Okay, with the domain. So we're going to think about our leftmost value first. So we're looking at the left, and we notice that this arrow is continuing, right? It's barely going to the left, but it is still going to the left. So -infinity, we'll just not put anything for that. Okay, and then, or for now, because we just want to think about what's going on here. So left continues on forever, and going to the right forever also. Okay, so this is going to be my domain of all real numbers. Okay. Well, what that means is that x is the set of all real numbers. Okay, x is in the set of all real numbers. All right, so domain, how we write that in interval is negative infinity to positive infinity. All those values in between. Range. Okay, so let's think about the range here. Minimum, right? Starting at my minimum, I'm going up and down, kind of using my pencil to help. Okay, so I've got nothing down here. Nothing down here. And the reason I know that is because this is an asymptote. Okay, if you see that dashed line, it's an asymptote. We get very, very close, right? But it doesn't cross or even touch that value. Okay, so that's where I start. All right, so I've got shaded in here. Okay, so my lowest value is -3. Okay, but now the question is it less than or equal to or just less than? All right, so this one's going to be just less than. All right, and again, the reason is because of that asymptote. I am not touching at that -3. If you were to, try to find a point there, it would not exist. Okay, if you were to plug that function into the calculator, right, and then see what happens at -3, it's undefined for your x value. Okay, because it's not part of the function. All right, so -3 is less than y, and we're good on that. And then over here for interval, okay, your lowest, not touching, right, parentheses, so not touching, all the way up to positive infinity, because it just continues up forever. There is no peak, right? It's got that arrow, it's continuing and not stopping. Okay, so those are some examples of interval and, find a domain with interval and set builder. Okay? All right. Symmetry. Okay, so a few different types of symmetry from graphs. Okay, I'm just going to do some quick sketches. We're not going to focus on this too much. It's relatively simple. Okay, so x-axis. Another word for this is like a reflection. Okay, all right, and we'll just kind of go through here. This is also a reflection. All right, and then for the origin, it's a little bit different. It's actually a 180-degree rotation. All right, and we'll see what that entails. All right, so here's an example of x-axis symmetry. It would be something like that. Okay, something like that. All right, where you have a graph. Okay, it's not a function because it would be evaluated at two different spots, but it's still a relation. Okay, it's still a relation. And essentially, just the fancy definition of this is for every point, x comma y, on the graph, say the point, the point x comma -y is on the graph. Okay, and what I mean by that, all right, is for every point on the graph. All right, so let's say this one right here. Let's use something else just because maybe the twos make it more complicated than it needs to be. But this one right here. Okay, so that coordinate is 4, 2. Okay, so and what this is saying is for every x comma y on the graph, the point x comma -y is also on the graph. So that would mean that the point 4 comma -2 would also be on the graph. And let's check it. Okay, 4, -2, also on the graph. Okay, so that's kind of a fancy definition. But again, it is just a reflection over that x-axis. Okay, that's what the symmetry, that's what the x-axis symmetry is. Okay, y-axis is exactly what you expect it to be. It's just symmetry over the y-axis. Okay, so let's say it's something like this. Okay, so we've got a little quadratic. Boom. Okay, now what this one is, the formal definition is for every x, y on the graph. The point, well, let's think about it this time. Okay, let's look at the points that I have. I have 2, 3. Okay, and then the kind of similar point here is negative 2, comma 3. So the only difference between these is you've got a negative. Okay, so this one is for every x comma y on the graph. The point negative x comma y is on the graph. And it's office hours time. I will finish this video in just a sec. Okay, and then for the last one, origin rotation. All right, this is a little bit weird, but it's kind of like the cubed root ones. Okay, so like this. All right, so you got a little rotation like that. Okay, and now the formal definition. Okay, this is for every x comma y on the graph. The point. Okay, again, let's think about it this time. All right, so this one is 4 comma 2. Okay, let's think about what this one is. This is negative 4 comma negative 2. Okay, so therefore, for every x, y on the graph, the point negative x, negative y is on the graph. Okay, and that is origin symmetry. Now, one way to think about it is that 180-degree rotation. So think about it, right? You're taking this and you're rotating it all the way around, and it should match up with this over here, right? So you're flipping this piece 180 degrees, and you're going to end up with this same shape. All right, and that is origin rotation, and that takes care of this video. We're not going to get too detailed into the points here. As long as you can identify which one's which, you are good to go. All right, y'all take care.